Welcome to a new video by Wiskunne English. In this video we're going to talk about system of equations and how to find out how many solutions a system of equations has. So we're not going to calculate the solutions, we're just going to find out how many solutions do we have and how does it work. So I'll start with an example. We have 3 variables and 3 equations. So we have as many variables as equations. And when do we have a solution or solutions? When the rank of the variables, so the rank of the small matrix or the variables, is equal to the rank of the big matrix or the rank of all elements, or the rank of the matrix of all elements. So the first matrix is 2 minus 1, 1, 1 minus 2, 1, 1 minus 1, 2. So I'm just taking the numbers that are in front of the variables, so you know x is equal to 1 times x. The other matrix is equal to 2 minus 1, 1, 1, 1, minus 2, 1, 2, 1, minus 1, 2, 3. So, we have the small matrix and the big matrix. And I said, if the rank of this is equal to the rank of that matrix, then we have a solution or solutions. Now this is a 3 by 3, this is a 3 by 4. If you don't know what the rank of a matrix is, of how to calculate the rank of a matrix, watch the video about rank of a matrix. Now, I'm going to calculate the determinant of this matrix. So I have 2 minus 1, 1, 1, minus 2, 1, 1, minus 1, 2. I will not use row operations. You can use row operations, but I'm just going to calculate it. So I'm using the first row. So I have 2 multiplied with minus 2, 1, minus 1, 2, plus 1 multiplied with 1, 1, 1, 2, plus 1 multiplied with minus 1, minus 2, 1, minus 2. If you don't know how to calculate determinant, watch the video of determinant of the video of how to calculate the determinant of a matrix. So we have this, so 2 multiplied with minus 4 plus 1, minus 4 plus 1 is minus 3 is 6. 1 multiplied with 2 is 2 minus 1 is 1 plus 1. 1 multiplied with minus 1 is minus 1 plus 2 is 3 plus 3. So we see we don't have 0, we have 10. So the determinant is not equal to 0. So we have 10, which means that the rank of this matrix is equal to 3. Now we see that the first 3 columns are equal, so the rank of this matrix is also 3. When we have as many variables as equations, and we have the highest possible rank, which is in this example 3, then we have one unique solution. I already said that we're not going to calculate the solution. In an upcoming video, we're going to calculate the solutions, but here we're just going to find out how many solutions do we have in each example. So in this example, we have a unique solution. Now suppose the determinant of this matrix is 0. So next example. So we have again 3 variables and 3 equations. I will write the small matrix 1 minus 1, 1, 2 minus 2, 2, minus 1, minus 1, minus 1. So what do you see, that the second row is 2 times the first row. So if we calculate the matrix, we can use the determinant of the matrix, we can use row operations. You can see that we can do row 2 is equal to row 2 minus 2 times row 1. And if we do that, we get 1 minus 1, 1, 0, 0, 0. So we get a row with zeros, which means the determinant is equal to 0. Now, I can use a 2 by 2 matrix to see if the rank is 2 or 1. A 2 by 2 matrix, for instance, I take this one. I have 2, -2, -1, -1. So I have 2 multiplied with -1 is -2. -1 multiplied with -2 is plus, but with minus in front of it becomes minus again. So we have -4. So the rank of this matrix is 2. Now, we have the big matrix. One, -1, 1, 1, 2, -2, 2, 2, -1, -1, -1, 3. Now, you can ask, do I need to calculate all the 3 by 3 matrices to see if the rank of this is 3 or 2? Because then you need to calculate 3 3 by 3 matrices, which is not that it's easy to do, but it's a lot of work. But there's another method. If you see the combination, what did I say? Is that row 2 is equal to 2 times row 1 with a small matrix. Now, if this is also equal to 2 times row 1, it means that it follows and that we have solutions. Yeah? For instance, if I say my brother and I, the age of my brother plus the age, my age is equal to 60, so I say x plus y is equal to 60, but I say 2 times my age plus 2 times my brother's age is equal to 130, you see, this isn't correct, because this must be 120 to have solutions. So, when it's 2, you have solutions. When it's everything except 2, you don't have solutions. So you can calculate every 3 by 3 matrix and you will see that the determinant of every 3 by 3 matrix is equal to 0. Or you can find the linear combination. So you can find that row 2 is equal to 2 times row 1. So this must be, if we want solutions, then this must be equal to 2 times row 1. So here, the rank is 2, which means that, like I already said, this row is 2 times that row. So we have 2 rows, because we can remove this row, because this row already says what this row says. So we have 2 rows instead of 3 rows. So we have a parameter, because the rank is 2. So we have the small matrix, the rank of the small matrix is equal to the rank of the large matrix is equal to 2. So you see that we have 1 0 row, or that one row tells the same as the other row. So we have an infinite amount of solutions because we have one parameter. Now, when do we have 0 solutions? I already said it. We can use the same example and change it a little bit. So, not 2 but 3. If I'll calculate the determinant, for instance, of the first 2 columns and the last column, you'll see that it's not 0. Or that the rank of the small matrix is still 2, but the rank of the big matrix is 3. So you don't have solutions. So we have 1 multiplied with -2, 3, -1, 3, plus 1 multiplied with 2, 3, -1, 3, plus 1 multiplied with 2, -2, 1, -1. So we have -2 multiplied with 3 is -6, plus 3 is -3, plus 6 is plus 9, 2 multiplied with -1 is -2, plus 2 is 0, so you see we have determinant is 6. So not equal to 0, so the rank of the small matrix is not equal to the rank of the big matrix, or we don't have solutions. So, brief summary, when we have as many equations as variables and we have the highest possible rank, then we have one unique solution. When we don't have the highest possible rank, but the rank of the small matrix is equal to the rank of the large matrix, then we have an infinite amount of solutions. When the rank of the small matrix is not equal to the rank of the big matrix, we have 0 solutions. I hope you enjoyed this video. Please drop a like and subscribe to the channel.